Hello everyone, hope all of you are doing great. And in today's video, we're going to discuss paper 2, unit 1, number and calculation in the classified book. Remember that in this paper 2, you can use the calculator. All right, but not in every single question. Like in this question, for example, over here, they're saying to give each answer as a power of 6. So we agreed that here I want it as a power of 6. So it means that the base is 6. So 6 to the power of 8 divided by 6 to the power of 2, we minus the indices. So it's going to be 6 to the power of 6. All right, the next one over here, they wanted also as a power of 6. So they wanted the whole thing at 6 to the power of something. We already know that 3 times 2 is 6. So as if the saying to you 6 times 6 to the power of 3 times 6 to the power of 4. So we're supposed to add the indices 1. Oh, don't say this is 0. No, it's 1 plus 3 is 4 plus 4 is 8. So 6 to the power of 8. All right, let's continue. The next page. The next question, I mean. Here it says to you, Eco has these number cards. He chooses two of the number cards, or she. She multiplies the numbers together, find the maximum possible answer she can get. It is not going to be here, for example, don't think about the largest two positive numbers, like 5 times 3 is going to be 15. Yes, 5 times 3 is going to be 15, but this is not the largest product that she can get. Actually, if I multiply -8 by -4, it is going to become positive 32. So the largest or the maximum possible answer she can get when she multiplies two of these cards is -8 times -4, which is positive 32. Write down two possible values for the number when the square of a number is 64. The square of 8 is 64. Yes, Mr. But they want here two possible values. So it is positive 8 or negative 8. Both of them, because if you remember, we said square root of 64 is positive or negative 8. So it's positive 8 or negative 8. Here, the number 12.25 has two square roots. Find them both. Let's use the calculator for this one. I'm going to use the calculator. It's paper 2. I'm allowed to. So I'm going to go to the calculator here. And I'm going to say square root of, here is the square root of 12.25 equals SD. It is 3.5, Mr. 3.5. Good, thank you. Put the calculator away. So it is 3.5, positive and negative. 3.5. Calculate the square root of 74. Give your answer correct to one decimal place. I'm going to get the calculator again. 74 square root of 74. SD 8.602. All right, but they wanted to one decimal place, mister. So it's 8.6. Look at the digit after the 6. Strong or weak? Is it less than 5 or 5 and more? No, mister, it's less than 5. So the 6 stays the same. If it was, mister, for example, 8.65 or 8.66, so in this case, it would have been 8.7. But here, after the 6, I have a weak number. So it is going to remain the same, 8.6. Let's continue. Here, work out 1 plus 2.5 squared minus 1 plus 2.5 squared. Oh, there is a difference. They're not the same. Here, I'm going to add what's inside the brackets first, and I square the answer. So it's going to be 3.5 squared. 1 plus 2.5 is 3.5 squared minus, here it's 1 plus, what is 2.5 squared? 2.5 squared only. It's not anything else. So it's not that the whole brackets or the whole pair of brackets are going to be squared. No, it's only 2.5 squared. Don't waste time on working this out. It is paper 2. So you're going to find that 2.5 squared is actually 6.25. Or you could have just written in the beginning 2.5 squared this way equals SD 6.25. So here 6.25, which means that 3.5 squared minus 7.25. Do it on the calculator. No need to waste your time on working this out. Here you're going to find that 3.5 squared minus 7.25 equals 5 exactly. Next question says to you find the value of x. Here it says to you 9 to the power of 3 times 9 over 9 to the power of 6. So what is 9 to the power of 3 times 9? It is 9 to the power of 4 over 9 to the power of 6. It means subtract, Mr. 9 to the power of 4 minus 6, which means 9 to the power of negative 2. Let's continue. Write 252 as a product of its prime factors. Here, they want you to do the prime factorization. You got two methods, either the factor tree, which I actually do not prefer with big numbers. I prefer with big numbers to avoid any confusion. I prefer that you, just a second, let me erase this. I prefer the stick method. What is the stick method? It's just for large numbers to avoid any confusion. We just do 252 and we divide only by prime numbers. What is the prime number that I can divide 252 by? I can divide 252 by 2, which is going to give me 1. Yes, you can do the long division or you can do it on the calculator even. It's paper 2. So it's going to give you exactly 126, 126. Again, what is the prime number that you can divide 126 by? A prime number you can divide 126 by? It is also 2. It's going to give you 63. Another prime number that I can divide 63 by, you're going to find that it is, you can say it is 9, or you can say it is 7. It doesn't matter. Both of them are, 9 is not going to be corrected, and the 9 is not prime. I need a prime number that I can divide them by. You could have said also, someone else could have said, Mr. I can divide it by 3 or by 7. Both of them are correct. So dividing it by 3 gives me here 21. Then dividing it by 3 again gives me here 7. Then dividing it by 7 gives me 1. So most important thing in this method is that you divide by prime numbers. So write 252 as a product of its prime factors. It is 2 times 2 times 3 times 3 times 7, which actually means 2 to the power of 2 times 3 to the power of 2 times 7. Next one here, this asking you to calculate this. Oh, mister, you told us that we're not going to take this here, how to calculate surds all by ourselves. Yes, you have to learn only how to estimate surds. And we took this in lesson 1.1, the irrational numbers. But to calculate it, no, they gave it to you in paper 2. So you are allowed to use that calculator. So to do this first, I need to do what? I need to put the fraction sign. Here it is. And up there, I'm going to write square root of 7. So square root of 7. And then I need to get out of the root. So you need to move with the arrow one step to the right. And then you add 4.1. But it is cubed. So I'm going to go to the cubed button, which is here. I'm going to put the index here and I write the 3 by myself. Or I could have just pressed Shift X squared. It gets you cubed. So now square root of 7 plus 4.1 to the power of 3 over, you need to go down, 3.1 times 0.2 equals, it gave you 115.4302. You don't have to write it all, just maybe like 3 digits maximum because they did not determine exactly how many digits or how many decimal places. So 115.430, you can stop there, or 115.43 and stop there. Be careful. The digit after it is a weak digit. So it is 115.43. We're not going to round up. All right, next here is the same thing exactly, but I can simplify it first here before going to the calculator. It's 1 plus 12 squared. We know that it's 144 over 2 times 9, because 3 squared is 9, is going to become 18 minus 13. And we did the multiplication first. So here, simplifying it more, it's 155 over 5. So what is 155 over 5? It's going to give you exactly 31. All right, next. Complete this calculation. The thing to you 4 squared equals, well, I need first to do 4 squared. It's 16, mister. 16 times is 16 is equal to 2 times. مستر هو definitely البراكتس دي هتجيب لي 8 لان this is 16 it's 2 times something 2 times what 2 times 8 يا مستر اكيد البراكتس ديت 8 so what plus 3 is 8 it's 5 5 plus 3 is 8 multiplied by 2 is 16 which is the same as 4 to the power of 2 535 as the product of its prime factors. It's good that we got here also prime factorization again to follow the same method. 735, we're going to write over here. Divide by a prime number. So divide by 5. So here, dividing it by 5, it's a prime number. Uh, Either using the calculator or using a long division, but it's paper 2. Don't waste time on working things out like this. Addition, subtraction, multiplication, division. Use the calculator. Here it is 1. Is going to give you here 4. Is going to give you, 1 second. I did here 1, remainder 2. So I got 4, remainder 3, so it is 7. Here, 147, you're going to find that it is divisible by 3. How did you know, mister? Because I know the divisibility rule of 3. Add all the digits up and check if they are in table 3 or not. 1 plus 4 is 5, plus 7 is 12. It is in table 3. So dividing it by 3 is going to give you exactly 49. All right, dividing it by 7 gives you 7. Dividing it by 7 gives you 1. So it is a mister exactly 3 times 5 times 7 times 7 again, which is 7 to the power of 2. Write down the smallest possible answer to this. The saying to you here, the square and this asterisk are positive integers. Both of them are positive. Square is a factor of 15. So let's list here the square is a factor of 15. Let's list all the factors of 15. We got 1, 3, 5, and 15. And they're saying to you that this sign is, the asterisk is actually multiple of 3. So 3, 6, 9, 12, 15. These are the multiples of 3, kind of like the times table. So they're saying to write down the smallest possible answer to this and this. Well, the smallest, I'm going to take it from 1. That's the smallest. The smallest factor of 15 is 1 times the smallest multiple of 3 is actually the 3 itself. So the answer, mister, is just 3. I didn't actually need to continue all of that, but I wanted you to understand what they meant here. The factors of 15 are listed here. The multiples of 3 are also listed here. I can keep going, but they want the smallest possible answer of this times this. So I got here 1 times 3 would give me the smallest possible answer. Here they're saying to you, take the expression that is closest to the square root of this. Just first, I need you to know that the square root of a to the power of 6 or the square root of anything that has an index, it just divides the 6 by 2. So the square root of a to the power of 6 is a to the power of 3. You divide only with powers, everyone. It's only with powers. It's a to the power of 3. You divided the 6 by 2. It makes sense, actually, because if I say to you a to the power of 3 multiplied by itself, you will say to me, mister, it is a to the power of 6. Yes. So it's a to the power of 3. So definitely, mister, I cannot take this. It's a to the power of 2. And I cannot take this, a to the power of 2. But mister, I got 3 a to the power of 3's. Now I need to work out the square root of 3 itself. What is the square root of 3? Go to the calculator. Square root of 3. Oh, just a second. I guess that I need to close the calculator and open it again. Yes. Just a second. Here we go. You're going to find here square root of 3 is going to give you as D 1.732. So it is 1.7. The only one that is correct is this one, 1.7. We agreed a to the power of 3. So it is this answer. Let's continue. Here is this saying to you the same thing exactly like the previous question. This is a multiple of 8. So it's either 8, 16, 24, 32, and so on. All right. But this is a factor of 15, which is 1, 3, 5, or 15. So if I say to you here, find the value of this and the value of this, the saying to you here, what? They both, if you add them up, they give you 45. So what are these numbers that if you add them up, they give you 45? Mister, I guess that we need to continue because here, if I add any two of them, they're not going to give me 45. So maybe, Mister, the next one, which is actually here, sorry, it is 40. I meant here 40, the next multiple. Now, yes, if I add 40 and 5, they will give me 45. So this one is 40, the multiple of 8 is 40, and the factor of 15 is 5. Here is a list of numbers. Write down the number that is a factor of 56. You're going to find that the only one that is a factor of 56 is 7. It is 7 times 8. Here they want the cubic root of 32. So you are allowed to use the calculator. So cubic root of 32, cubic root, shift square root is going to give you the cubic root of 32 equal to 3.174. But if you're going to stop at the 4, then you must write 3.175. Why? Because the digit after it is a strong digit. So it's going to turn it up to be 5, round it up to be 5. Or you can stop, if you stop at the 8, so it's going to be 3.1748 without any rounding because the digit after it is weak. So you can say 3.1748 is fine. 3.1748 is going to be correct. All right. Here, write a negative number in each box. So here to do this, you're going to need to write -8 here, and here you're going to need to write -3. So in this case, it's going to be -8 plus 3, which is going to give you the -5. 211 people go on a trip by bus. Each bus can take 16 people. Find the smallest number of buses that is needed. So here I'm going to say 211 people divided by 211 people divided by 16 is going to give me the number of buses. So let's do this using the calculator. 211 divided by 16. 211 divided by 16. SD to make it a decimal. So it is 13.18, 13.19 actually, 13.19 because I rounded it up. The digit after it was 7. So 13.19. Can you say this? Can I say to you, oh, we're going to need 13.19 buses? What do you mean, Mister? Are you going to get the tire of a bus or what exactly? So we need 14 buses. Okay. Here they're saying to you that Carlos writes down a 4-digit number. The number is a multiple of 3 or and 5. A multiple of 3 and 5. Well, Mister, if it two of its digits are square numbers, two of its digits are square numbers. Here you go. Two of the digits are square numbers. It's written over here, like 49. All right. Two of its digits are prime numbers. So here, prime numbers. Mr. Prime numbers, then definitely, you need over here a 5. Why, Mr.? Because they said to you it is divisible by 5. Divisible by 5, and it must end with 0 or 5 must end with a 0 or a 5. But if I put here 0, it means that it's not prime. It's going to be divisible by 2, which is not prime at all. So I must put that 5. I must put here the 5. Now it is divisible by 5 and it can be prime. Let's see here. 4, 9, to find it, if it's how come it's divisible by 3, to find out about this, you need to add all the digits up. 4 plus 9 is 13. 13 plus 5 is going to be 18. 18, I need here what? You can put here 3. If you add here 3, it will work because that's going to give you 21. If you put here 6, it will work. If you put here 9, it will work. If you put here 0, it will work. So in all cases, if you add them up, 4 plus 9 plus 3 plus 5 is going to give you 18, which is divisible by I agree here, this 13, 13 and 6 is going to become 19. Here 13 and 3 is 16. 16 and 5 is 21. The 21 is divisible by 3, yes, but this is not a prime number, mister. It is not a prime number, so I cannot take the 3. So 6 and 5, I cannot take it, mister, because it's not going to be a prime number. 9 and 5, it's 95, mister. 95 is not a prime number. I can divide it by 5. It's the only thing that you can put over here is 0, 5. So it is 4905. Now, this is a squared, as they said, and this is prime, as they requested, and the whole number is divisible by 5, and the whole number is divisible by 3, and all the digits up, they're going to give you exactly 18, which is divisible by 3. Are rational numbers? Well, rational numbers, I got here 8 squared and I got 19 over 6 definitely are rational because they can be written as fractions. And here, this is square root of 19 is irrational and pi is irrational as well. Here, what happened is that the x got multiplied by 4 to give you 4x. So multiply also the 8. So here, what is the number that I need to multiply by 4 to give me 8? What is the number that you need to multiply by 4 to give you 8? It is 2. So 2 over x, you multiply up and down by 4, gives you 8 over 4x. This is an equivalent fraction. Y to the power of 11 times what is y to the power of 12 times y, mister, which means y to the power of 1. You add the indices up, they give you exactly 12. W to the power of what to the power of 2 gives you W to the power of 10. It's W to the power of 5. All to the power of 2, you multiply them, they give you W to the power of 10. Calculate this. We agreed before that in multiplication or division, you can multiply or divide what is under the root normally. So this is equal to square root of 9, which is actually what? Positive or negative 3. So here they want you to write this number in the standard form. So it's going to be, mister, it's 5.8 multiplied by 10 to the power of, I'm going to move it 2 digits to the right. So it is negative 2, which is this one. Here, 15.66, mister, let's simplify this a little bit, minus this 1/4 is 0.25 as a decimal plus 3.15. This is a point. All is squared. Well, it's 15.66 minus 0.25 plus 3.15 is going to give you exactly 3.40, which is just as 3.4, but squared. Use the calculator and do it. Let's use the calculator and do it. It is here, as we agreed, 15.66 minus 3.4, but it is squared. So it's going to be equal to 41 over 10, which is the same as 4.1. 4.1 is the answer. Let's continue. Here, they want you to draw a ring around each of the rational numbers. Square root of 8,100. Well, mentally, you can tell that square root of 81 is 9, and I got 2 zeros as if they are 100, so it is 90. So this is definitely rational. Or you can use the calculator. It is also rational. You're going to find that it gives you an answer, which is 90. A fraction, definitely rational. Integer, definitely rational. Square root of 7, absurd, I can't. Cubic root of 8, it's 2, mister. It is rational. So these 4 are rational. They want you here to put these numbers in the Venn diagram. -7 is an integer. It's not natural. The natural numbers we agreed are only the positive whole numbers. Here, it is positive, negative, and 0 is integers. The rational numbers, you know, all of them are rational numbers, but add to them the integers is rational. The natural is rational, but add to them any fraction or decimal. So, okay, -7 is done for you. It is an integer. It's not natural because natural is only positive whole numbers. 12 is natural. Square root of 36, mister, square root of 36, that is equal to 6, which is natural. It's positive. 4.7 is not natural, is not integer because integers are all about only whole numbers, and it is rational, 4.7. Negative 55 over 11, mister, that's equal to negative 5, which is an integer. So negative 55 over 11, it is an integer. Negative 2 over 3, that is rational. It is a fraction, and it's not an integer. It's not the natural number. Here is a list of words. Complete the sentence using the correct word from the list. Square root of 3 and square root of 5 are examples of irrational numbers. That's it. Thank you so much, and see you in another video.